My name is Satvidve. I provide online classes for students of grades 1 to 10. I do it for various subjects like science, maths, social science, English, etc. I also take online classes for various competitive exams like National Science Olympiad, National Maths Olympiad, National Talent Search Olympiad, examination, SSC, CHSL, among others. Currently, I am preparing for my SSB interview that is due to be held in September. As I am mainly a defense aspirant, and I cleared my CDS examination quite recently, last year itself. I completed my graduation from Dayal Singh College, University of Delhi. Uh, I have an overall teaching experience of around 2 years, and for the past 1 years, I have been taking online classes. So before I take much of your time, let me quickly move on to what I have for today's demo video. Okay, so let me start my screen sharing. So guys, here we have this question from trigonometry, and we have to prove this equation. So we are given the LHS and RHS, and we have to solve any one of these. So traditionally, like mostly we solve it through LHS only, but it's your choice. You can solve it either way if it's possible. So I'll do it from the LHS only. So taking LHS, we have uh, root of 1 plus sin A divided by 1 minus sin A. So how we move on with this question is, since we have to achieve this and there is no under root in our RHS, so we have to make sure that we remove this under root to solve to it further. So what we'll do is we'll multiply the denominator and the numerator and the numerator with root of 1 plus sin A. Okay, so what we'll do is in the next step we'll simply apply this. So root of 1 plus sin A divided by, oh sorry, just a second. So 1 plus sin A divided by 1 minus sin A into, we will multiply both the denominator and the numerator. So 1 plus sin A in the numerator and multiplying the same in the denominator as well. Okay, so of course this won't change the nature of the equation altogether, so we can do that. So now we take it under a big under root. So we have 1 plus sin A into 1 plus sin A is 1 plus sin A whole square divided by 1 minus sin A into 1 plus sin A. Okay, all of this is in the under root. So if we observe closely, so what we can see is that we have 1 here, we have 1 here, we have sin A here, we have sin A here too. So if we take 1 as A and if we take sin A as B, so we clearly get the identity of here of algebraic identity of A minus B into A plus B. Okay, so we all know that it equals to A square minus B square. So we will simply apply it here too. Okay, so when we apply this, what we get? See, we get under root of, sincere apologies for the handwriting, under root of 1 plus sin A whole square will go as it is under the under root, and 1 we have A square, that is 1 square minus sin A whole square. Okay, this gives us root of 1 plus sine A whole square divided by, yeah, divided by 1 minus sine square A. So what this gives us? 1 plus sine A under the under root, and we have 1 minus sine square A. So we all know that we have this identity of, let me show you how I got this. So we all know that we have this identity of sine square A, this trigonometric identity, sine square A plus cos square A is equal to 1. Okay, so we all know this. Now when we take sine square A here on the other side of the equal to sign, then we get cos square A is equal to 1 minus sine square A. So we will simply replace sine square A with 1 minus sine square A with cos square A in the above equation. So we get under root of 1 plus sine A whole square divided by cos A. We'll take it in the whole bracket because they both have squares. So this square will get cancelled out with the under root, and we have 1 plus sine A divided by cos A. Okay, so when we uh, sine A by cos A. So what we simply did, we separated both of them, like we solved them separately, and then what we'll get, we all know that the reciprocal of cos A is always sec A, plus sin A by cos A is always tan A. So we had to prove this only in the RHS, and we got this at the end. So this is basically our answer. So we will simply write here, hence proved. So here you all can see that we use the approach of using various trigonometric identities as well as algebraic expressions. So that made it easy for us to solve the given equation or to prove this. So we got this at the end. Hope you all liked this video, and keep watching these kind of videos. It was really great having you all. Thank you and have a nice day.